Basically, I'm just going to move this from here. I'll delete this. I will also delete this, and I'm going to paste it here, and I'm going to start from here. So when we talk about boolean or boolean, so this is just what represents what we call true or false, and then there are only two values there. For example, if you say 4 is equal to 5, now this is like saying 4 is equal to 5, which is not possible because 4 is not equal to 5. But when you are comparing two numbers, we use this double equal to. And when you say that 4 is equal to 5, you evaluate them using what we call boolean or booleans, or whichever way you call it that is okay for you. So this tells you what to use in comparing number, either it is true or false. For example, you can also say 1 or 0. Are you coming today? If you tell somebody 1, that means true. If you tell somebody 0, that means false. So the same way when you're making a comparison boolean, so boolean represent the two values, either it is true or false, and that's what we are talking about. So if you say 2 plus 2 is equals to 4, is either it is true or false. So in that way, you see what I did here. If I change this into 4 and rerun this again, you will see it is going to be true. So it is either representing true or false. So if you look at this, if I say 41, for example, is equals to 4, is going to be false because 41 is not equal to 4. So remember, when you're making a comparison, you use 2, but when you're not making a comparison, you use 1. Like if you go ahead and run this now, you're going to have an error because this cannot work. So the only way you are going to make a comparison is by using 2 of this, and it can either be true or it is false. Now in that way, in programming, we need to express it, either it is true or false, and you evaluate true or false. So whichever way you do, it is either telling you it is either true or false. Now what I'm trying to say is, if I say that 10 is greater than 2, this will be either it is true or false. So, and it is actually true because 10 is greater than 2. But if I say that 10 is less than 2, what will it be? It is going to be either true or false, which is going to be false. So this is the way you can evaluate numbers. And like I said earlier, when you're making a comparison, you use this way to make a comparison. So if you have 10 here and you say is less than 2, so you are expected to check whether is that statement true or false. So as you can see here, that this is false because 10 is less than 2. So let me start by adding this here. So let's go ahead and make a print, and let's also go ahead and make a print. So if you evaluate these two, you see that this is false because 10 is not equal to 2, and then 10 is not greater than 2. But if you say here that you should print 10 is greater than 2, and you run this, so you're going to have true, that is false, and true, because this is the only one that is true here. So in this way, when you are making a condition, or if any of your statements if, so you can make it in such a way that is going to return either it is true or false. Example is, let's say that x is equal to 2, 3, and then y is equal to 7, and you say if a statement, if x is less than, okay, let's say if x is greater than y, then in this way we can say print So in this way, you can use this using if or else. So if means if it is true, then now you're using a conditional statement. If it is true, then print this, but if it is false, print the other one. Now I say that x is not greater than y. So if it is true, then that means it's going to be this. So what bring these things, because you're using a conditional statement here, you can also use less than, and then if you turn this to less than, it is going to say x is greater than y, because you have said that if it is greater than, if it is, sorry, x is greater than y. So which one is it going? Because x is greater than y. Now here, this is 3. Remember that you said if it is greater, print this, but if you change this to less than here and you run it, it is telling you that x is not greater than y. So all these things, if you also make a comparison here and they say that x is equal to this, so you now says x is not greater than y. X is not greater than y. So depending on the statement, whichever way you put it, this is just like trying to make evaluation, and this is you converting uh, your statement true or false and putting it using if or else statement, which is what we call conditional. So in that way, so you can actually evaluate two things. Like here, it is just you trying to say whether it is true or false, or here you are trying to use a conditional statement to check your statement. Now in evaluating numbers, you can also evaluate a number you want whether it is true or false. So what I mean is, for example, if you say here that you want to check boolean, like the way we use strings, so you use bool like this to now check your distance. So I'm going to go on with printing bool is equals to this. Now this is true because I am trying to make a kind of casting. Remember what we did last time, where you evaluate this, so you put strings or integer to a particular thing. So you're trying to put bool in here. So the same thing, you can also use the same thing here when it comes to numbers. So I'm going to change this thing from what we have here to, let's say, 24, and you run this and you can see that this is true. So what I trying to do, you use bool function to evaluate any number and it will either give you true or false. So this is just a way you can actually evaluate numbers. So in that way, you can also check whether print, the moment you put this bool here, it is just trying you to evaluate. So it is either it is true or false. This is just what you can get from a particular number that you're putting true or false. And then in most cases, we also say you can also use it in different aspects. Like you can use it in tuple, you can use it in list, and then you can also use it in string. So whichever way you do that, that's also going to work. The moment you put bool like this, and then you now go ahead with either strings, like the way I put Lydia inside there, then and you run it, it either return for you, it either true or false. Then you can also put numbers inside it and you run it as well, it is also returning. This is just like you evaluating. And you can also put lists, so, or put a tuple. We are going into that, but I'm just using that as an example. Like I can go ahead and say this one, I'm going to put Lydia in there, and then I'm going to put Farida in there, and I can run the same thing. So this is supposed to be comma, and if you run this, it is going to return this. It's just like you evaluating. So it is either it is true or it is false, like I said. So you either make it true or it is false. So whichever way, you just need to understand that you use this to evaluate a number or whatever you want to evaluate, to check whether is it a function, is it true or false. So with that, it can return for you whether it is true or false. So this is just what you can do with Boolean. So it is not a long distance. So we might not be spending long time on it, but you just need to understand that when you evaluate two things, and you can check whether it is true or false. So on that, I'm going to go into operators. So when we talk about operators, alright, so when we talk about operators, we are basically talking about what we use in performing operations on variable and values. So we are going to be talking about basic simple thing, and then there we can use that to build what we need to build. Now, example, anytime you use a plus sign, you add things together. Now, one of the practical example is using a plus sign. So if you say print then plus 45, then when you run this, the operators automatically add up this number for you. So anything you can go ahead and do, you can basically use this plus sign to add it up. Now, for example, simple mathematics, when we say 2x minus y is equals to 10, for example, and then when you want to go ahead and start solving, for you to get the value of y or something like that, or for you, let's say 2x plus, let's say 3 minus 3 is equals to 10, for you to get the value of x inside this, so you need to now make this the subject of the formula by moving this into this. So you are going to have 2x is equals to 10 minus because when this 10 plus, because when this cross the sign of equality, it becomes this. So you have this equals to 3, then you go ahead with 2 is equals to that is 13, and then you return back here, and then you say what is the value of this. So you still have 2x here, so you are going to have x is equals to 13 over 2. So in this way, you should be able to have the value of x. So if you have this and somebody say this plus this, and you need to find the value of it. So now we are going into using all these numbers, like the way you use your calculator, or the way you make a computation in class, or the way we are going to be talking about building an app that can convert longitude and latitude, adding it to the coordinate, and should be able to give you the next coordinate. So we are going to be using this another scientific part aspect of it. So this is what we are going to be using. So in this way, like I said, when you're talking about the operator, so when you say let's use this for the rest of the basic things, so you see now that if you have this plus this minus this will give you this multiplied by this will give you this, and this divided by this is going to give you this. So generally you use plus sign in making addition. So this is just what you got to do. So in this way, you can as well create a number. When you're talking about addition, so you can just say, let's say 40, and then you add it plus 10, and then when you run this particular this, and then you print, for example, let's go ahead and say print add, then you should be able to have 50. Now here I just went ahead and add, that is, go ahead and print for me, but here I defined a variable, and then I said this is equal to this, then print that particular number for me. It was able to give me this particular number. So you see here the different thing I just did. Now you can also add another number. Let's say add 1. You can also add what is already existing into another number. What I mean is that I have defined add. I can also do add plus 50. Now what it means is that if I print add 1, now what it means is that I have added number to other numbers. So what I did here is that add, I have defined the add, and I say add is equals to 10. 40 plus 10 is equals to 50. You can see here the first one is printed. Then in this number that I've added, I've decided to add this number again into this existing number. So I have to add another number. That gives me one, that is 50 already added, plus another 50 is 100. I can also decide to make another addition. So let's go to add 3, and then I can say add 3 is equals to add plus add 1. Now if I print add 3, if I print add 3, so let me just go ahead with printing, I'll just put in add. So if I go ahead and say add 3, what happens? It is going to add all of them for me. Remember, it is now making it a cumulative because I've added this here, then it gives me 50. Then I say add 1 is equal to add, which is 50 plus another 50 is 100. And then I say here cumulative of both of them, which is here, the first one here is 50, the second one here is 100, and it's going to give me 150. So you can make this kind of addition, and the more you add two variables, and the more you continue to be working on you in that particular pattern. So generally, we are going to be talking about arithmetic operators, we're going to be talking about assignment operators, we're going to be talking about comparison operators, and we'll talk about logical, membership, bitwise, and identity operators. So generally, that's what we're going to be talking about. And when you're talking about arithmetic operators, now arithmetic operators are those things you make addition, those things you use in numerical value to perform like common mathematical those things used to perform common mathematical assignment. Now this is a table of contents. Okay, so I wanted to arrange it well so that you can see them a bit by bit, but let's go into arithmetic operators. You use them in perform difference, adding, common mathematics, like all those things you do is what we call arithmetic operators. So arithmetic. So when you're talking about arithmetic operators, it's just those basic things you use: a plus, addition, subtraction, multiplication, and division. So these are what I mean by arithmetic operators. So if you are talking about addition, it's just what I was trying to do here. Then subtraction, multiplication, division, exponential, there's floor division, and rest of them. So anytime you're making a basic operation or calculation, so you are referring to arithmetic operators. Now, one of the example is what I was just trying to say. For example, I say this, and then I say y is equals to, so I can just put it in numbers. Here, we can make a kind of print. This is for plus, so this will give you the value of this. At the same time, in under minus, you can also say print. You say x, you minus it by y. Can also say x minus y, and you close it, and now this become minus operators, that is subtraction. So you can also say here, you go ahead and still say print, open bracket, and you can say x, and then you multiply them, which is shift 8, and you multiply it by y, and this is multiplication operators. And then you can also here say in this one division operator, for example. So you say x, you divide it by y, and then this gives you a division operator. So you can see each of them. This one is addition, this one is subtraction, this one is this is multiplication. Now this operator is called division. So in that particular pattern, so once you have defined this, and like I said, we have modulus, we have exponential, and we have floor. Now let's evaluate each and every one of them. Now when we have here is, when you talk about modulus here, so this one we use it, that is modulus, that is percentage here. So where you have this, it gives you to floor. Now this one is exponential, which is raised to power. So raising to power means 23 raised to power 45. Then here under floor division is divide these things and give it a random number. To make this understandable, so I'm going to change this, and I'm also going to change this to 2 as well, and I'm going to run that again. This is 4, this is here, you can see this exponential, 2 raised to power 2 is 4, and then under floor is 2 divided by this is equals to 1. Now if you change this thing now to 4, for example, and you run this one, you understand that 2, if you take this divide by this, it is not possible, so it's going to give you, the only time this will work is if you put it here by 8 and you run this. I'm looking at the floor, you see now this is the floor here, so you still get up to this. Now these are different operators that you can actually use when it comes to addition, multiplication and subtraction. So this is what you can use. So here you add, here you subtract, here you divide, here you multiply, and here you lose, here you also do raised power, and this other one is floor. So in this way, these are basics, this thing you can use. So in that way, when you're talking about floor, it means that whatever you do, you need to round it up to the nearest integer. So, and that is exactly what you're doing when it comes to this particular one. So you bring it and you write it up, round it up to the nearest integer. All right, so this is sorry please. Okay, so this is basically a simple operation that we can do using arithmetic operators. So you add up this and then you divide this, and then this is just simply when you're talking about arithmetic. So you can also have some other complex ones which you can make a complex, so depending on how it is, but simply the ones you are talking about simple, you talk about arithmetic operator that you just need to like add something plus something by defining x and y, and then you just add them up, and that's just what you need to do in that particular pattern. So this is just basically when it comes to arithmetic operators. So you can divide, you can add, you can multiply, you can divide, and then so in that particular order. So this is basically what you can do when it comes to arithmetic operators. So now we are going to be talking about hold on please. Okay, so we're going to be talking about assignment operators. So when you're talking about assignment operators, in this one you assign it. So you assign the operator. 1 minute please. Sorry, I was having a call, so I wanted to settle the issue. All right, sorry. Okay, so when you're talking about assignment operators, you use them to assign uh, values to variable. In this way, it is the same thing. All of them works that same way, but the difference is that you have to like assign this thing to it. Yeah, so in that way, you can assign numbers, and then you can go ahead and say this is what I want you to do for me. Now when you go into assigning operators, equal to, you use that to assign a number, and that's what we have been doing when we say that x is equals to 3. So what it means is that you are assigning this number to this particular number. Now this same thing you have here, you can say this is equal to this, and this is simple. You are now trying to assign x into it. But when you now assign x and add something to it, for example, if we say that x plus equals to 3, this is just you making a kind of assignment. So you assign a number into a particular, like a variable. So you take values and you say this is what you are referring to, and that's automatically understand that this is what you are trying to refer to it. So in that way, you have numbers and you can say I want you to give me this particular value, and then it gives you that particular value. So what it means is, if you define a variable, like we say, you give it a value, and that value should be able to understand that this is what you are referring to. At any point in time you call that particular value, then it gets it for you. Now I want to now say that I want to give us numbers, and you say that the numbers you want to give, let's say that we say 3, and we say 4, and we say 5, 6. Just enter any number and you just assign all these to it. So I'm going to be using a bit list, though we have not gotten there, but I just want to assign, call all these number you have here as number. Then in this way I can print this number. If I go ahead and print it, that's going to give me this particular value that I have. But I can, the same time, like I was trying to say, I can also make a count. Like I want to know the number of number this thing is. Like we say last time, we are going to use length in order to ascertain the total numbers. So if you check the count of this number, then you see now that we are trying to assign this into it. So if you say here I'm going to say if the number that I'm going to count now is less than 3, for example, or let's say 1 2 3 4, so let's use 4. If it is less than 4, in that way I want it to print this particular number, or like this. So if you run these particular things now, you see that the count of number is greater than 4, because we have 1 2 3 4 5 6. So I want to remove one of the number here, so I'm going to delete 7 and run this, and I will say the count of number is less than 4. Then I want to remove this as well and leave it with only 3 numbers. Then it is telling me that the count of number is less than 4. So now what happened, I put up the number here and I want to know the total number that we have here. So, and I am trying to check what is the count. For the fact that I put length here, then what it means is that I'm trying to count the total number here, and since the total number here is greater than 4, you can see here this is greater than 4, so that means tell me that the number is less than 4. So I'm trying to make an evaluation, and I see here that this number here, 1 2 3 number here, is greater than, if you see here, you see 1 2 3 4 3, but here we have, I'm trying to evaluate whether it is greater than 4. So you can see here that it is telling me that the count of number is less than 4. Why? Because the total number here is 1 2 3. So if I add another number and add another number and I run the same thing here again, what happens? It says that the count of number is greater than 4. Why? Because 1 2 3 4. Now if you see the count, because we are talking about count, so it is going to be greater than 4. Now remember when I said using f string, so this particular thing I'm using, you can also use f strings to obtain this particular thing again. So I'm going to just copy this and make a modification on it. Inside here I can decide to add f string. Now what happened when I add f string? When I add f string, so it means that we can use the f string, which is bringing a formatting inside this. So I want to say the count of number as it is here is what I want to get in here. So if you now go ahead and use count, remember that we are putting a count here already. So you can go ahead and use the formatting string method here, which you are going to put up here. And remember, because you are using this goes into numbers. So what I'm trying to do is I'm trying to use the formatting because I want to know how many numbers that are inside there. So that's why I'm going to use a formatting f string. So you see here, this thing did not change because I did not put f string here. So I'm going to put f here. Now what do I mean? I want to know the count of the number inside here is greater than 4. So this is 5. So it already counted it because I'm using formatting string. So if I remove this number here and only leave this one, what happens is the count of the number here is going to be how many? 4, because this is 4. So it's already because of the f string. So I'm using the f string to count the total number. And I say once you look at it, count it and refer to the numbers here. So even if you enter more numbers here, for example, and then what the work is, the function of this count is that it should count the total number that is inside this list. So it is now checking 1, 2, 3, 4, 5, 6, 7, 8, 9, referring to you that 9 is greater than this. So you can make it any way you have is in it better. So you can say the total number in the list is, you can say is this, therefore this is greater than this. So for example, you can see what I'm trying to make here. So if I run this now, you see now it's telling you that the total number is in the list is 9. Therefore number is greater than 4. So I'm just trying to make a statement here. So you can make the statement whichever way you want it. Therefore number is greater than 4. So at every point in time you call this is what is going to give you, because you have said the total number in the list is, it will count the number of item inside here and then tell you that therefore it is greater than 4. So the same way you can also customize this yourself to make it work that way. So this is the way you can assign operator into numbers. Now how do you assign operator again? You use the aspect of using x is equal to, you assign a particular destiny to it, and you should be able to look into it. Now generally, when we will be making a kind of basic calculator, we can be putting all these things. Like for example, if you look at online calculators, for example, let me just check online calculator. Now some of the online calculators you try to work on, it shows you like this. Now some of them looks interactive, some doesn't look interactive. Like you look at this, you see now that if you say 8 plus 3 simply is going to give you this. But there are some other online calculators that can be interactive, that you can be maybe trying to access, and it is going to be giving you a kind of being interactive. So you can make your own, but this is just like a simple calculator where you can say something multiplied by 0 and then anything, and it's just going to give you this. So we can do this type of thing using this kind of basic operators that we are talking about here. So with this you can make this kind of thing. And for example, if you look at, let's say, BMI converter for example, and let's just start using this type of a thing, and you see now that you want to convert your weight, and you say what is your age, and you say are you male or female, your height, and if you calculate, you can see the way it is showing you here. So you are obese or not, obesity or something or like that. You can see here, this is an interactive what I'm trying to say. Now let me change that my weight or my height is let's say my height is 6 feet, and you run this. Now look at what is going to happen here. So you see the way it runs here. Now this is making it very interactive, and you can see that it is giving you a feedback here. It's different from the other calculator we're using, but you see here now that it is now making a calculation here, giving a kind of feedback. So this is just what I'm trying to say here, that you can make your output to give you this kind of feedback as you want. So when we go into working on basic calculators, then we are going to be doing that. Now another thing I want us to try quickly is what we call the comparison operator. So when you're talking about comparison operator, this is just what you use to make comparison, like what I have said earlier. When I say 5 is equal to 5 and then you run this is going to be true. And you can also make another comparison by saying not equal to, by using this particular operator sign. So if you say not equal to, that means you are trying to refer to. So this particular arrow here, this is what is telling you not equal to. So anytime you want to say not equal to, you use this particular one. So this one is not equal to. So this one, when you are seeing not equal, you use this particular one here. Then you can also use another one like we have used earlier. This is greater than, or this is less than. So whichever one that you want to use at any point in time, this is greater than, this is less than. And you can also use greater equal to by using it like this. So let's say you can make something like this, greater equal to, or even you can also use less than equal to, whichever one. So you go to less than equal to a particular distance. So in this way you can use comparison operators. So in comparison operators, you basically use them to compare two values, whether it is true or not, or whether it is false or not false. So in nutshell, you use them in making comparison. Now example of what I'm trying to explain is that let's say that x is equal to 10, and let's say that y is equals to 5, 6, or whatever you want. So you can make a comparison on them by starting saying that let's say that x is equal to, you go ahead with y. So what does this trying to tell you? You are making a comparison, and the answer will be that it is true or false. So as you can see here, it is telling us that it is false because both of them are not the same thing. And then you can also print that it is not equal to by using this particular one. And if you go using this one, so that means first start with what you want to compare, and you say that it is not equal to y. So I'm going to run this now. You see now that is going to be true because x is not equal to y. You can also use greater than. How do you use it? By saying that x is greater than y. So this will return either it is true or false for you. And then you can also say that x is less than y. So I'm going to say x is less than y, and then when you run this, you should be able to have it true or false. So the same way you say equal to, greater than, or not equal, or not greater than, you can also modify that by saying greater or equal to. So by using this sign, or greater, less than, or and equal to, you can also use this sign. So when you run this, you should be able to make a comparison with this. The first one is true, false. The second one is true. The third one is false, true, and false. So you can use this to actually check whether it is working or not working. So as well, you can also make a kind of chain of comparison, not just only using one numbers like the way we are using here. You can also make a kind of chain comparison. Remember when we're talking about mathematics? So let's say that we say that x is equals to 10 here, and you want to make a chain of comparison. So that means you can go ahead to say that 1 is greater than, 1 is less than x, or at the same time, which also like the chain of comparison, the way we used to make it in school that time when we were making mathematics. So you can use a chain of comparison here, that is x is less than and also less than 10. So you see this is false because 1 is less than x less than 10. So you can also make the comparison as that, like that. You can also make a comparison by using and as well. So here you have that x1 is less than x, and you can also say and here, and then this one. So you are trying to make a comparison. Remember what we were talking about using and. So both value must be true. So here this is false, and then when you put or here, then you remember what we talked about using or and. So the same thing is applied to this particular one. So you can make a kind of comparison using this one. Then other comparison you can make are just what we call logical comparison using what I am talking about now, or and or not. So in this way, you call it logical comparison by the way we used to like make a logical comparison between numbers. So either you put and, or you put or not. So each of them works in for you. So I'm going to like talk about and. You can use and here, or you can use not. So in this way, so you should be able to have make a comparison between two numbers, and then come up with where either it is working or not working. Now in the aspect of and or, you can decide to use and. In and, you can, when you are making and comparison, so we have defined that x is equal to 10, and you want to make and comparison. So in that way, you need to put the number in such a way that both of them is going to evaluate what is here and what is here. So in the aspect of, let's start with and, for example. So we go in here. For us to work on this, we need to start at x here, which we have defined is greater than a particular number or less than a particular number, and then here you are making a comparison between both of them. So in this way, you are working on and let me treat them one after the other. So you are working on and. This is false because you are trying to evaluate one particular number, and you are making whether it is and. So you use this particular way to make a comparison between two numbers, and at the same time you can also make a comparison between this at the same time. Or now, like I said last time, when you're using or, any of the statement can be true. So if you look at this, you see that x is less than 10, then or x is less than 10, or x is greater than 10, sorry, or x is greater than 10, because both of them are the same thing. So this is false. So any of the statement can be false. You remember one, when it is true and when it is true, what happened? When it is false and when it is true, what happened? And when it is false and when it is false, what happened? So in that particular pattern, you should be able to get to know what you need to know. Then in this part, or not using this, you use not, and when you are using not, you use not outside the brackets like this, and then you now make your comparison when you are using and. So I'm just going to copy this part and also copy this part, and I'm going to highlight it, and then I'm going to close the brackets. Then when you run this, you are making not. So that means, remember when I say 0 against 0, and then 1 against 1, and then 0 against 1 and 0 against 0. So we use those things in making a kind of valuation. So don't really get this too serious. Just what I want you to understand is the basic aspect of it. So how do you get to work on it? So don't get this too serious. Simply, so I'll be stopping soon, and then you can ask me question and we interact on those numbers. Then before we go, because I want you to understand just the basic operators, we need to talk about a bit when you are trying to check whether a particular thing is in existence or not in existence. So in that way, this is what we call identity operators. So you use that when it comes to identity operators, you use that to compare objects, not if they are equal or actually whether they are the same, but to check check it within the same memory location. So you can use is or not. I think I have used this a bit before when I was telling us that is not in the beginning, when I was talking about is and not. So I think somewhere around here, yeah, so we talked about it a bit. So it is also a way of identifying is there also a way of identifying whether something is in or not. And I think I remember that day I used is and I used not. So it is still that just the same thing. So you can come up with a variable and to check whether is that thing inside there or not inside there. So you can make such kind of comparison using is. So if for example I want to say that a is equals to, so let me just use lists, and I'm going to say Lydia, and I'm going to say Ame, and then I'm going to say Farida. So let me just put them in here. So I'm using this. So this is A, and then I want to go to B, and then I can also decide to use the same thing in A and B at the same time. So I can now make comparison with all of them. So whichever way. So what I try to say is, let's say that I say B, and let's say that I say B is equals to almost the same thing that I have here. So let me just also paste it here, and then I go ahead to say C is equals to, let's say that C is equals to A. Now in this way I can now say that I want to print this. So let me just go ahead to print A is in C, or to print A is in B, or to print A is equal to, that is making a comparison. Now what I mean is that I have A and I have B, and both of them are the same thing, and I want to say that A is equals to C, that C is equals to A, and I want to say to print A is in C. So that means if A is equals to C, so that means it is true. And when I say that A here is B, so if you check B and if you check A is B, so it is not the same thing. So you see here A is B, that is this one is B, so it's going to give you false. But when I say that A is the same thing as B, so that means both of them are true, because Lydia, Ame, and Farida is the same thing, so that is true. But when you declare A and B, they are not the same, because A is a different variable, B is a different variable. So A is B is not true, because both of them are not the same variable, even though the item inside of them are the same thing. But when you talk about A and B, they are not the same variable. So this is how you make a kind of identity comparison. So you make this kind of comparison. So in another way around, you can also make this kind of comparison. Let's say you want to print let's print A is not B. So let's run this, and you see that this is true, because A is not B. The item are the same thing, but invariably they are not the same thing. So you can also make the difference either using the number, you can use a string, or you can use float, or you can use an integer. So this is just generally what you can use when it comes to making a comparison. So yeah, go ahead. This one we call it identity. Go ahead.
Yeah, morning, sir.
Yeah, how are you doing?
I'm fine.
All right.
I want to know about those operator above.
This one
Uh,
or this one?
no, yes,
This one?
above, above.
This one?
Yes, here,
Okay,
yeah.
okay, this
On
one.
this,
Okay, this one is called logical. Okay, so let me write it in full. This is comparison operators.
Okay.
Now this one is comparison, when you're making a comparison, when you're talking about comparison operators. But when we get here, this one is called logical. So this one have to do with logical, because you are making a logical, like is it true or not true. So this one is called logical operators. So we talked about arithmetic, which is using plus and sign. We talked about assignment, which is assigning. We talk about comparison, which is checking using equal to or not equal to. We talk about logical, which is making a comparison using either big or not. Like if you have x here, you define x. You remember when we were talking about equality and inequality in mathematics? So it is logical. So you use this to compare them. Then this is identity. This is what we call identity operators. Yeah, go ahead.
Okay. I want to ask it. I have a question.
Mhm.
This on logical.
Okay.
Come again on logical. Yeah. This code below.
Okay.
Print x less is less than 0 and the x is less than 10. For this code, I tried to make like what you did.
Okay.
So for me, they told me you have to find for x. So I want to know how for hi. This one below. Yeah, this one. For me, they told me to define for x first.
Okay.
So I want to know why
Okay.
for you they don't
Work for you.
define x.
Okay. Okay. No problem. Give me a moment. You will share your screen, and then we see what you have there and correct the error. Is that okay? All right.
Okay.
Okay. So this is, like I said, this is identity, and then one more operators. Okay, go ahead.
Good morning, sir.
Yeah, how are you doing?
I'm good, and I have a question on the identity operator.
Okay.
Would you please run this code of A is not C, so that we can get uh, yeah, can we run like print A is not C?
Like I say, print like this. Print A is
Is
not
not C.
C
Yeah.
in this particular one. Yeah, because
Yeah.
A is not C, it is false, because A is actually C, because you have said A here and you have defined finally that C is equal. So if you say it is not, that means you are lying, right? So it is going to be false. You get it? Because A is actually C, which is true. When you say that A is not C, it is false, because you have declined here is the same thing. C is equals to A, and yeah, so if you say that A is not C, that is not true, because A is actually C. Is that okay? And you remember, this is identity when you're talking about operators, so you need to look at it. You know, this is why some people mathematics is complex for them, because you need to think about it. But if you look at this, you see that you have said A and B, and you now come ahead and say that A is equals to C. It's just like you saying, you remember when we are talking about like, look at this. If I go ahead and say here, print A. Now, what is he going to give me? He's going to give me Lydia. And if I say print C, what is he going to give me? He's going to give me the value of Lydia. Why? Because I've said whatever that you have in A, everything you have here, I have added it here. So if you now say that A is not C, it is wrong, because you have already said that A is equal to C, which is the first thing you did here. Is that okay? Okay. Okay, so membership operator is used to test if sequence is present in an object. Like I said, you use it to check whether is it inside there, and I have talked about it before. Example of what I've taught is just like to bring these things. We have talked about it before a bit, but now we are talking about it in the aspect of we are talking about it now in the aspect of operator. So you check whether it's there or not there. How do you check it? Like I said, I think I used checker that day. Yeah, I remember. So let me still use the checker. So when you say checker is in A, so you need to check this. So this is membership operator. So there is no checker there. But if I change this and put Lydia, what happened? It is going to be false. What happened? Lydia in A.
It's typing error. You type Lydia and Lydia.
Oh, that's true. I was like, what is happening? All right, let me type it well. It seems like I don't know how to write her name. Okay, yeah. So you can see here. Thank you. You know, this kind of a thing is the reason why you say it run for him and it did not run for me. And you're like, where is it coming from? Not knowing that I make a little bit swapping. So you can see here, this is true. So this is how you can check in whether it is not. And when you want to check is not, you still use this way, and then not, you put not here. Now is a keyword that automatically it understand. Lydia is not in A. Now this also revert back to what Honore we're discussing here, because this is present. So if you said it is not in there, it will tell you is a false. Like you say Lydia is not in A, it will tell you no, Lydia is in A. So you are lying. This is false. And that's why you have here. So you use in or not to check. And the same thing, you can also check a string. Yeah, you can also check a strings. And then in strings, I'm going to use D, and I'm going to say that D is Honore. Now you can also check a strings as related to that. So you can say in here that you can go ahead and say that print to know whether H Honore is inside the D. So in D. Now you can check it by checking the string. So you can see true Honore is in D. And if you go ahead with small h, this is false because we don't have this Honore inside there. So you can check in using like this. You can also check it using this format. So I'm going to type it like this. So I'm going to say Honore like this, and then I'm going to make this. So if you run this now, you see now that this is true because it is contained there. And if you go ahead and remove R here to type it here, it is false because there is nothing like that inside there. So what it means generally, you can also check a strings, that is membership of strings, to see whether they are existing or not existing. So this is what we call membership operator, whether they belong to that category or they don't belong to that category, or they are something related to it, or they don't something that you're saying is not related to it. So this is a way you can operators, you can check for membership. So home. Okay, so this is a way you can check for membership. And also we thought we use what we call Bitwise, which we call I might not be going deep into this, but for those in full time, maybe Honore can go deeper into this if he is. But what I just want to say is I just want you to know it, so that at any point in time you run this type of thing, and you will be asking yourself where is it coming from. So you just need to have a little bit knowledge of it. But it is called, we used to call it Bitwise, and when it comes to Bitwise, you use it to compare binary numbers. So binary numbers, like each of them, like you can use and, or you use not or, that's X no, not, you use left 0, signing auto the right, and as well. So most of those things are actually used in binary. So remember when we were talking about binary last time, I was trying to tell us how do you write Lydia in binary. So I think it is in this class that I talked about how binary interpret binary number, and I was like, how do you write Lydia in binary? And then example is putting Lydia, and then if you want to convert this to binary code, so you can see this is the meaning of Lydia here. As you can see here, this is Lydia in binary code. So this is majorly used when you're talking about binary, and that's why we call bitwise operator. So in binary, this is what Lydia means. This is what computer sees when you type Lydia. You're seeing this, but binary, this is what you're seeing. So the same thing if I put honore here, and then the same thing in conversion. This is honore in binary, and if I put ame here, and then you convert it, it goes in this particular pattern. So everybody, look at, imagine when you are saying Lydia is sleeping when the class is going on. Now you have this number, this is what you type, but this is what it means in binary. So you can see how large it is going. So these things I typed here, you can see what it means when you're talking about it in binary. And this is what the computer understands as you're typing. So it's big, and you can see here, like I said, binary, you can use not equal to, you can use up, and rest of them. So it is bigger this thing, so which probably you might not be interested, but when you're talking about binary, so you can use different of them. You can use this as well. Then this is when you're talking about binary, so you can go ahead to get more on it. And then lastly, when you talk about operators, we call it precedence operators. So this one used to describe, majorly it describes the order which operators are performed. So you can use that. So we call it precedence operators. So in precedence operators, basically you use it to describe the order in which operation are performed. For example, when you are talking about like using parentheses, you say use parentheses in preceding, meaning that the expression inside the parentheses must be evaluated first. You remember when we're talking about board mass, we say bracket of division, multiplication, and subtraction. So that means if you are working in a big distance, so what it means is perform what is in the bracket. Like, let me just give you example of what I'm saying. You know, when you're talking about you're having different operators, when you have different operators, so you use this way to make such kind of performer check first, finish what is in the bracket, and then you go ahead to perform what is outside the bracket. Remember when we are talking about board mass, we say bracket of division, multiplication, and subtraction. So when you use this kind of operators as well, when you use the precedence operator, so you are giving it this kind of instruction, finish what is inside, and then before you go ahead with what is outside. So this is exactly what I mean by that. So example of what I'm saying is that, let's say for example that you have a bracket and you say let's say 5 let's say 5 minus 3. When you say 5 minus 3 and you go at 5 minus, let's say 5 minus 4, then you go ahead and have another minus, and then you say 5 minus 3. Now what it means is that you are telling this instruction, taking instruction, take this one first before going to this one. So in that way we call it, this is the order it goes. So if you put this in bracket and you run this, I should be able to give you first 5 minus 4 is 1. Then 5 minus 3 is 2. So 1 minus 2 is equal to minus 1, and this is how it happens here. So we call it preceding. So the moment you have this kind of a thing, you're trying to tell it finish with this one first before you go to another one. Don't jump it. So you put them in bracket. And the same thing even when you're doing multiplication. Let's say you put board mass and you say, let's say 10, and you say plus another number, let's say 10 plus another number 4, and then you can also say multiply it by 4 as well. So what it means is that treat it 10 minus 10 plus 4 is 14, and then multiply by 4. So this goes into the bracket to tell you this is what I want, and you need to know each of them in that particular pattern. So this plus this, remember board mass, and if you can remember board mass, which is bracket of addition, subtraction, multiplication, and division. So if you have this, it have to actually get this one done for you first before you go ahead to score it off. So what I'm trying to say is that multiplication has higher precedence than addition, and therefore multiplication are evaluated before the addition. So what happens here, because board mass, remember bracket of, so let me type it here, board mass, bracket of, sorry, I did not put it well, bracket of, or evaluates, they say they have changed it, division, multiplication, and subtraction. So ideally what board mass means is here, because the multiplication have more power than addition, the first thing it have to do is 4 times 4 is 16. 16 plus 10 give you 26. But if you're looking at it normally, it's supposed to be 10 plus 4 is 14, right? 14 multiplied by 4, that's going to give you 14 multiplied by 4, that's 28, and 28 again is going to give you around 70 something or so. So you see now that it gives you the order of how is it going to be performed. That's just, it gives you the order how is it going to be performed, and once it recognize that particular order or pattern, so it goes ahead and make that evaluation. So it is called precedence operator. So it checks using this formula to tell you that this is what you need to do at this time, or this is not what you need to do, and it follows that particular pattern. So this is exactly what you mean when you're talking about precedence. So those order you need to know is that it is called precedence order, and it describes you how it goes in. We have the parentheses, we have the exponential, we have different orders. But what I just want you to know is that it uses those way and tells you this is how it's supposed to go. And remember, like I was talking about board mass, those things are what they have defined in mathematics, that it ought to go in that pattern. So even if you go ahead and have something that have to do with addition and subtraction at the same time, so what it goes is that first, what are you trying to say? So it uses that order to make a distance. So if you ideally, if you ask what is the answer of this, so what we say is 6 plus, you will say here 6 plus this is 9, 9 minus 5 is 4, 4 plus this is gives you 11. You can see here the addition and subtraction have the same proceeding, but multiplication does not have the same proceedings. So you should understand that. So it have to evaluate it from left to right, because addition and subtraction have the same proceeding. They have the same has the same order proceedings. But when you put multiplication, it's not the same thing again, like what happened in the beginning here. So the precedings are not the same thing. So it is an operator, and in that pattern, that's how it get to understand how it works, and then should be able to know that I need to start from left, I need to do this thing first. Like you see here, this goes in here first to do, goes to the right first before coming to the left, but this one goes from left to right, so we call it preceding operators. So generally we have talked about operators, and we talked about from arithmetic to assignments, then we talk about comparison, logical identity, member, bitwise, and we talk about preceding. So these are operators we are going to be using. And then before we'll be moving to Python lists next time. That's the next thing we're going to do, which is list. But before then, remember what I told us earlier. For example, we want to make an input. Don't forget that I'll be using this. Let's say that we have A is equals to addition input. Remember this very well, because we are going to be using this when we'll be writing a kind of calculator. We are going to be using this. So this thing is very, very important, and I want you to remember it very well. This close the brackets, then also close the bracket. So don't forget this. So you can see here, input the first number, then 5, input the second number 8, then you can see here. So when we want to make addition, we can say A is equals to, that is A minus B. Then let me say addition is equals to A plus B. Then subtraction is equals to A minus B. Multiplication, mod, is equals to A multiplied by B. And then division is equals to A divided by B. Yeah, so you see these things. Now this is what we should be using when we'll be making a simple distance. So we'll be using this kind of input. So you see here is asking me what is the first number. I'm going to say 1. What is the second number? I'm going to say 4. What happens? It read the rest of other distance here. So you have A plus B, B plus C. So for us to get this executable, so we need to now go ahead and say print. So this is okay. I want to leave it in that addition. Yeah. So let me just say print all of them. Yeah. Print A addition. So because I don't want to break, I don't want to remove it. So you can say print addition, so that you can have the value of addition, first number, and then second number, and then you can have the value for addition. So remember this, because we are going to be using this often. So we can also put, I think, subtraction. Yes. So we can also print multiplication and division. So you have all these written such that if you take in a number here and 4, and then take another number here 8, and you can get in here. Remember what I said earlier, that you can say you can still add something here to make it more interactive, because me, I don't know what is this. So I can go ahead and put a number here and say here, this is the product of addition. I'm trying to let it make a little bit sense for us. Now if you look at this, you see now if I run it now, so let me just copy whatever that is here and then paste it here, then also paste it here, then also paste it here. Then something is wrong here. What is wrong? This thing is supposed to come here, this one also supposed to come here, this supposed to come here, and this also supposed to come here. Then space here, sorry, control Z, space here, and also space here. Then this one is going to be subtraction. This this is going to be multiplication. This one is going to be division. Sorry, division. So what I'm saying is that you can see here I'm making it more reasonable so that anybody who look at my output, who was that? Addition. Yeah. So you can see here I've made it more interactive in such a way that the first number I've added is this, the second number is this. This is the product of addition, which is 7 plus 5. This is the product of multiplication, subtraction, which is 7 minus 5. This is the product of addition. So you can make it interactive like this, and this gives you a pure understanding, because like I said, we are going to make this happen. So a small calculator, we can just create a small calculator that gives you an overview of how to get this thing done. So we can, what I'm saying is that don't forget this, so we can be using this, and you can see the way I make it interactive here, so you can see the product of what you have here. So if you look at some of other code that I use in working, you can see that I can make it interactive here to actually give you the feedback of what you are doing better than what the way you have it. Like if you look at this aspect, you see that each of them have an output that you can read, and it makes meaning to you that this is the what is the product of what you are looking at. And if it is an output that you're looking at, you should be able to say that what I am looking at, this is the output of what I have done so far. So it is making more sense when you have make it so much interactive. So you can say this is what you are looking at, and this is the output of what you are looking. This is the output of what you are looking at. So if you look at this, you see that this is what you use in processing data. So as you are looking at it, each of the line have to tell you that this is what happened here. This is also what happened here. So you can see the different imagery being stacked, and you can see here where I enter my username. Each of those steps have the output that you can read and understand that this is what I am trying to refer to here. And you can see the imagery I'm trying to process. You can see the output of the date. So each of them, you can see the Sentinel-1 satellite, the location. So you can see this, the output. You can see when it is downloaded. This is when it processes to digital elevation model. Then each of those steps where you have the output are being guided for you. You can see now the topography of the radar of the place. There is the azimuth. Then you can see now the output. This is the filtered phase, so you can see the imagery on that particular pattern. You can see the correlation on that pattern. You can see the unwrap phase in that pattern as well. You can see each of them going in that pattern. So what does this mean? It means that each of those things you're doing, the code and how it shows now gives you the right output perfectly with the you understand that this is what I'm trying to do here. So what I'm saying is, it is necessary you make like the way you're making a kind of evaluation to see that this is what it means here and this is what this does not mean here. So in general, why I put those things is to let you explain. Even when somebody is reading your code, the person should know this is what you put here, because the person might not be having this. Because when we switch to, maybe when we start using Python like this, when we are going to start using this, you might not be seeing, the person who can be seeing this, and if the person is seeing this, not understanding what you're saying, if there is no output that looks like this, as you can see here. So if there's no output that looks like this, I made this thing in interactive in such a way that even if somebody see this running, you know what it is doing, and you know that this is what the person is looking at here. You can see building overlapping in Sudan. The person knows that, oh, in Sudan we have about 3,399 building overlapping in the entire Sudan. So the person can understand. But if I don't make it interactive like the way, if I remove all these things I put here, somebody might be running the code, and because the person is not me, the person might not really understand what I'm trying to talk about.